dear friends, welcome back to our YouTube channel. This is our ADC instance. So in this class, I am going to introduce the step-by-step procedure to reduce the given quadratic form into the canonical form by using the orthogonal transformation. Right? Now I am assuming that Q be the given quadratic form with three variables, x1, x2, x3, three variables. So, the first step is to find the real symmetric matrix A. As we know, the quadratic form Q is equal to x transpose AX, where x is the variable column matrix x1, x2, x3, because only three variables. What about A? Is the real symmetric matrix. So, real symmetric matrix means A transpose equal to A. Otherwise, Aij is equal to Aji. I represent number of rows. The row, J represents the column. So when you go for A12 is equal to A21. Go for A23 is equal to A32. That means this is the symmetric matrix. Now, how to get the symmetric matrix? Very simple. In the given quadratic form, collect the coefficients. So this will give x1, this is the x2, this is the x3, right? And this is the x1, this is the x2, this is the x3. So first one row x1, second row x2, third row x3. First column x1, second column x2, third column x3. Let us collect the coefficients. So then we'll get x1 square, x1 into x1, x1 square. So collect the coefficient of x1 square, put it here. When we get x2 square, x2 into x2, x2 square. So the coefficient of x2 square is the middle diagonal. And when we get the x3 square, x3 into x3 is x3 square. So the coefficient of x3 square is the third diagonal. Right? Now coming back to the first row once again, x1 into x2. This matrix is symmetric. So what about mean that x1 into x2 both are same. Right? So collect the coefficient of x1, x2 and divide by 2. Collect the coefficient of x1, x2 divided by 2. Similarly, here we can substitute here the same x2, x1 or x1, x2 the same because it is a symmetric matrix. Similarly, x1, x3 is a symmetric matrix, so it is x3, x1. So x3, x1 where here. So collect the coefficient of x1, x3 divided by 2. Divide by 2 the coefficient of x1, x3 by 2. What about this one? x2 into x3. Similarly, it's a symmetric matrix, so x2 into x3. So collect the coefficient of x2, x3 from the given quadratic form. Divide by 2. Divide by 2. Collect the coefficients. Once I repeat, collect the coefficients because it's a symmetric matrix. So the diagonal, we put the coefficients of square value. x1 square, x2 square, x3 square. This is symmetric matrix, so these two are similar. So take the half of the coefficients. These two are similar, so take the half of the coefficients. These two are similar because of this symmetric matrix. Right? So this is the very first step. And from the second step, we use the real symmetric matrix alone to determine the eigenvalues of A. So this is a 3 by 3 matrix. That's why there are 3 eigenvalues, namely lambda 1, lambda 2, lambda 3. And third step to find the corresponding eigenvectors, namely capital X1, capital X2, capital X3. And fourth step, very important, very important, because the fourth step is verify that they are pairwise orthogonal vectors. Please kindly go and watch the separate video I made for the orthogonal vectors, pairwise orthogonal vectors, as well as the length of the eigenvectors. So please go and watch. Now the fourth step, verify that they are pairwise orthogonal. So how to verify the vectors are pairwise orthogonal? Let us multiply the two eigenvectors, one with the transpose. When we get 0, then we say that the vectors are orthogonal. So there are three things. So x1 transpose x2 0, x1 transpose x3 0, then x2 transpose x3 equal to 0. Then we say that these three eigenvectors are pairwise orthogonal. Okay. So once they are pairwise orthogonal, let us proceed further. If you fail to get the pairwise orthogonality, let us construct the eigenvectors in such a way that they are pairwise orthogonal. Understand? And the fifth step, construct the normalized monomatrix. So I also made a separate video to construct the normalized monomatrix. What is meant by normalized monomatrix? Is a normalized monomatrix is nothing but a matrix whose column vectors are nothing but the normalized eigenvectors. If you see that we got the x1, x2, x3. x1, x2, x3. So namely x1 is x1, x2, x3. So find out the normalized eigenvectors. What's normalized eigenvectors? Divide by its length. What's the length of the first eigenvector? Nothing but sum of the squares of the eigenvectors. x1 squared, x2 squared, x3 squared. Let us divide them by L of x1. With this each value, this will come in the first column. Similarly, I have the second eigenvector. Find out the length of the second eigenvector. Divide its length, each of the values. We get the second column vector. And third column vector is nothing but the from the third eigenvector. So normalized model matrix is nothing but whose column vectors are the normalized eigenvectors of x1, x2, x3. And if it is the normalized model matrix, they are already pairwise orthogonal. So automatically, this normalized model matrix is an orthogonal matrix. What's the orthogonal matrix definition? Yeah, please go and watch a separate video. When we say that the matrix is orthogonal, yeah, n transpose equal to n transpose n equal to I. And sixth step, diagonalization. So diagonalization is a separate video, separate topic. When we extend the diagonalization only, we get the canonical forms. So once the diagonalization is happened only for the real symmetric matrix. That's why very first step, the matrix must be real symmetric matrix. And fourth step, the vectors are pairwise orthogonal. Otherwise, we can't able to get the diagonal matrix B. What is diagonal matrix B? It's nothing but your diagonal matrix. Only the diagonal elements are non-zero, the others are zero. That means that the diagonal elements are nothing but the eigenvalues of the given real symmetric matrix A. So once we found the eigenvalues, we know the diagonal matrix. So D equal to lambda 1 0 0 0 lambda 2 0 0 0 lambda 3. Why this is only 3 by 3 matrix? Because quadratic form contains only 3 variables. So A is also 3 cross 3 matrix. That's why there are 3 eigenvalues, 3 eigenvectors. So this is also 3 by 3 matrix. This is also 3 by 3 matrix. How will we get this D? This is by using the orthogonal transformation. N transpose A. What is the N? N is the normalized form matrix. Now the final step, the seventh step, how to convert this to the canonical form. So canonical form is nothing but your perfect square terms whose the coefficients of the square terms are nothing but the eigenvalue. Is lambda 1, lambda 2, lambda 3. Now this we can get it from the given quadratic form x transpose A. So take x is equal to ny. This is called the normalization matrix. N and y is the new set of variables, the outcome variables, right? So here y equal to y1, y2, y3. Why I consider only 3 variables? Because x with the 3 variables with the quadratic form with 3 variables x1, x2, x3. That's why we consider y equal to y1, y2, y3. What is called n? N is the normalized model matrix and they are orthogonal. So this transformation is called the orthogonal transformation. Is that right? Let us substitute x equal to ny. So ny transpose A into ny. So this property is there. AB transpose. What's the AB transpose in the matrix? AB transpose equal to B transpose into A transpose. So this ny transpose becomes y transpose N transpose. A into ny. I can combine these middle three matrices N transpose AN. This is from the previous step. N transpose A is in the diagonal matrix B. So D. What about D? Lambda 1 0 0 0 lambda 2 0 0 0 lambda 3. What is the Y transpose? Y1 y2 y3 and Y is y1 y2 y3. When we multiply all three matrices, we get lambda 1 y1 into y1 square, lambda 2 y2 into y2 square, lambda 3 y3 square. So we get only the perfect square terms, but whose coefficients are nothing but the eigenvalues. So this is known as the canonical form. So this is my required canonical form from the given quadratic form by using the orthogonal transformation. So these are the 7 step-by-step procedure to reduce the given quadratic form into the canonical form. I hope everyone understand this concept. Please just watch some more videos depends on based on this reduction of quadratic form into the canonical form. Thank you. Thank you so much.